Hello, today we're going to work on solving and graphing absolute value inequalities. The last lesson you did was just on solving absolute value equations. Now we're going to do inequalities. All right, so we're going to skip these warm-up questions and we're just going to go ahead and get started. All right, so solve and graph each absolute value inequality. Well, how do we do that? All right, so we've got a few steps. Let's go back up here so I can make a list for you. All right. Step 1, isolate the absolute value. And I'm going to call this ABS, all right, absolute value. So isolate it, get it by itself. So like this guy, you see how he's not by itself? The absolute value has things over here. We need to get rid of this 5, we need to get rid of this 3. All right, so step 1, when you're solving these, always isolate the absolute value. Step 2, determine if it's an and or an or. All right, and the way we do this is you remember all right, bear with me for a minute. I'm writing faster than Smart Notebook can keep up. All right, so we remember less than great or. Forgive me, folks. I'm getting really impatient with the Smart Notebook today. G-R-E-A-T-O-R. Okay, more on this in a second. So less than great or. So if you've got an absolute value inequality, you have isolated the absolute value first. If you have a less than sign, it's going to be an and relationship. If you have a greater than sign, it's going to be an or relationship. All right. The next step, 3, is to solve it. Solve for x. And step 4, finally, you're going to graph. Also here with the solve, you want to check if necessary. All right. All right, so let's scroll down. Let's do this. Step 1, isolate the absolute value. Well, looking at A, our absolute value is already by itself. So that's step done. Next step is we need to determine whether it's an and or an or. Remember what I said about less than? So this is a less than sign. So this is going to be an and relationship. All right, because the absolute value is already isolated, we can go ahead and split this into our 2 equations. So x is less than 7. Something special you need to remember about absolute value inequalities. When we split this, remember how with a regular inequality, we have what's inside, with a regular inequality. We have whatever's over here, and if we multiply or divide by a negative number, we have to switch the operator. In the center, we have to flip it over. We got to do the same thing here. Because remember, with an absolute value, when you split it, you say inside is equal to the right side, and then inside is equal to negative the right side. So because of this making that other side negative, we have to flip the operator on our second side. So I have inside is equal to the right, is less than the right side, exactly as normal. Then I'm going to say left side is greater than negative the right side. Okay, so remember, you still have to make the right side negative for your second one. And because this is an inequality, when you make it negative, you have to flip that operator in the middle. Okay, so 2 steps. Now, this is isolated, this is solved already. I don't have any other algebra I've got to do, so we can go ahead and graph this guy. So I know I'm going to have something happening at -7, something happening at +7. So let's look here. First one, x is less than 7. All right, less than, not equal to, so open circle going to the left. X is greater than -7, greater than, not equal to, open circle, and it's greater than, so going to the right. And this is an and relationship, so I want just the overlap. All right, and that's my answer. Go back to the next one here. Look, this is a greater than. So remember I said great or. So this is going to be an or. So once again, we can go ahead and split it. Remember when you're splitting it, one side, your first equation is inside absolute value, same operator. Right side, the second one, inside the absolute value, flip the operator, make the right side negative. All right. Once again, this is already solved, so we can go ahead and graph it. I know we've got -4, we've got +4. All right, greater than or equal to 4, so that's going to be filled in circle going to the right. Less than or equal to -4, filled in circle going to the left. All right, and this isn't or, so this is all we do, because or, remember, is union. We want everything, so this is all we do for this guy. All right, let's do one more on like this. All right, this is greater than. So remember great or. This is already isolated, so we can jump straight to that step. Split it, one side normal, for x is greater than 28. Other side, other equation, flip the operator, make the right-hand side negative. All right, then we solve for x, which is our step 3. So I'm going to divide both sides by 4. So I get x is greater than 7. Divides both sides by 4. And I get x is less than -7. Once again, we can graph this, and this graph is going to look pretty much just like our other or graph here. Greater than 7, less than -7, open circles because they're not equal to. All right, so far so good, right? I'm going to flip the page, you're going to scroll. All right. These are more of the same. All right, they're isolated, so we determine it, then we split it. So let's just go through real quick and let's identify whether these are and or ors. All right, less than, remember less than, so this is an and. Greater, less than. All right, and I do want to deal with the F. I'm going to show you this example because of the fraction. I want you to see this. Fractions are nothing to be afraid of, but I want to specifically show you how we deal with ones where I've got my x on top of a fraction. All right, so let's split this guy apart because my absolute value is already isolated, so let's just split them. So first side normal, second side, second equation, flip the operator, make it negative. All right, so let's solve. I'm going to subtract 2 from both sides. So I get x over 2 is less than or equal to 3. And then this 2 right here is being divided. So how do I get rid of something that's being divided? I multiply. So I'm going to multiply by 2. That cancels out, leaving me with just x is less than or equal to 6. All right, now let's do the other equation. Subtract 2. So x over 2 is greater than or equal to -7. Once again, multiply by 2, multiply by 2. So x is greater than or equal to -14. All right, then we graph it. Negative 14, 6. All right, less than or equal to 6. So filled in dot to the left. Greater than or equal to negative 14. Filled in dot to the right. This is an and, remember? So we do want the overlap. So I copy my endpoints and draw the line in between. All right. So now let's get, and actually I want you to see, yeah, we'll do both G and H. All right. So first off, remember our first step. Do isolate your absolute value first before you determine whether it's an and or an or. All right, this will be important for H here, but let's take a look at G. All right, so I want to isolate my absolute value first, so I have to add 1 to both sides. So that gives me x minus 3, the absolute value of that, is greater than 5. Now that it's isolated, I can go ahead and split it. So I have first equation, just copy as normal. Second equation, flip the operator, make the right side negative, and then solve. So plus 3, x is greater than 8, plus 3, x is less than negative 2. All right, did you all notice what I forgot to do? Yes, I skipped step number 2, determining whether it's an and or an or. So right here is where I should have done that once we had our absolute value isolated. So look at the symbol. Greater than or less than? It's greater than, so great or. This is going to be an or relationship. So we're going to graph it. I know I've got something happening at 8, something happening at negative 2. So x is greater than 8. So open circle to the right. X is less than negative 2. Open circle to the left. And this is an or, so that's where we leave it. All right, going back to H. And this is, again, probably the most difficult one on the page, but this is one I specifically want you to see and why I want you to see that we don't determine and or before we isolate. All right, so watch. We have to isolate the absolute value is our first step. So I'm going to subtract 2 from both sides. Hang on one moment.
Excuse the interruption. Jimmy Gann, that delivery should be here in probably 20 or 30 minutes. Thank you.
I don't know if you all could hear that announcement, but maybe it'll make you feel like you're in school today. All right, so I subtracted 2 from both sides, so I get negative 3 times the absolute value of 2/3 x plus 4. Excuse me. Excuse me, is less than or equal to negative 12. All right, then I need to get rid of this negative 3. So I'm going to divide both sides by negative 3. So I get 2/3 x plus 4. Remember, when I divided by a negative 3, I've got to flip the operator. Less than or equal to, and negative 12 divided by negative 3 is a positive 4. All right, so let me show you why we don't determine whether it's and or before we isolate it. Because if I looked up here, I'm seeing less than, I'm thinking this is an and. But once I've isolated all of this, and I come down here, I have the absolute value by itself, look at that, I had to flip it. So this is actually an or graph. It is not an and, it's an or. The other reason we don't want to make this determination before we have isolated it is because what's our rule about absolute values? They can't equal a negative number, right? Up here, this was less than or equal to a negative 10. Absolute value, that's your instinct. Wait a minute, something's wrong here. But we're good. All right? Because when we divided by that negative 3, it made it positive. I am going to go ahead and split this guy. We'll probably not graph him, but I am going to split this guy because I want to teach you how to remind you how to deal with this 2/3 right here. All right, so let's go ahead and split. So 2/3 x plus 4 is greater than or equal to 4. For the second equation, 2/3 x plus 4. Remember, we flip the operator and we make the right side negative. Okay, so let's go over here. Let's solve. -4 minus 4. That leaves me with 2/3 x is greater than or equal to 0. Positive 4 minus 4 is 0. All right. Then I'm going to multiply to get rid of this fraction. I'm going to multiply by its reciprocal. And what you do to one side, you got to do to the other. All right. These cancel out. Dealing with x is greater than or equal to, well, 0 times anything is just 0. So this side is greater than or equal to 0. All right, let's do the other side. Once again, I'm going to subtract 4 from both sides. So I get 2/3 x is less than or equal to -8. Multiply both sides by my 3/2. Come on, there we go, there's a 2. All right, those cancel out, leaving me with just x is less than, and let's determine this. -8 times 3 is -24, divided by 2 is -12. All right. And this is an OR graph, so why don't we go ahead and just graph it, right? It won't take that long. So I got something happening at 0. I have something happening at -12. This is a 0, not a 6. At 0, I'm greater than or equal to 0. So I'm going to the right. I am less than or equal to -12. Draw that to the left, and that's it, we're done. Good luck with your homework, and as always, email me if you have any questions. Have a great day.